Okay then, HSRP, right? This is your one of your redundancy protocols, and this is the topology that we're going to use. And we all know that redundancy is very important in a network. Therefore, Cisco has created this redundancy protocol, and it wasn't just today that they did it. This has been around for a while, and obviously, I got some notes here. Ta-da! Okay, and I got this. I think the date up here. Yeah, Cisco created 1994, so this thing's been around for a while. And here are the other two redundancy protocols, and the year they were created, 1999, and then GLBP in 2005. HSRP and GLBP, two Cisco proprietary protocols. This is really the one that provides true redundancy, or load balancing, I should say, load balancing. All right, but they ask you a quick couple questions on it. Again, look at the Cisco course that I have up there. It goes into a little more detail than we do here in the practice labs. And the other one is VRP, which is the industry, across multiple vendors. The only difference between HSRP or one of the differences between HSRP and VRP, while people wanted to go to it, not only was it a multiple vendor, but the timers were faster at that time. That's not the case now, obviously. Now, the one we're going to do is HSRP. All right, and HSRP, as you can see, is organized into standby groups. Yes, you create a standby group within the interface. All right, one's active and one's standby. The command is standby. It's not HSRP. It's standby. You'll see it now when we configure it. All right, but it's all based on you create a standby group, one through one or two or whatever it is. You create that group, and then after you create the group, okay, you then give it a priority. The higher priority, that router becomes active, and the other one becomes a lower priority, becomes a standby. All right. Now, what you need to do is create what it says there, a VIP, or choose a VIP, which you're going to put into your client, which is a virtual IP. And looking at the topology, all right, if you look at this, if this client is connected to, to a switch that's obviously connected to two routers going to, let's say, an ISP to go out to a web server, what have you, for redundancies in case this goes down. But if you have one gateway, there's only one gateway. You don't have multiple gateways. You have one gateway. There you're going out. And this one, if you look at this particular PC, the gateway is 254. Okay? So that means that the traffic, if I were to ping this web server, should go out this way. Now, we already have full connectivity. I am running the RIP routing protocol on here, so we do have connectivity. So let's do this. Let's go ahead and ping, right? Let's look at our IP first so you can see it again. All right, and we're going to ping. Okay, so we're pinging. What's the? I'm sure it's this. Oh, it's just this. Oh, okay, no, maybe not. Hold on. What am I using? Oh, 2. Okay, I'm using 2 this time. All right. Let's ping 2.2.2.2. All right, we see the Ethernet. We get the ARP. So, come on. Really? Okay. All right, so something's definitely going flaky here. I'm going to wait for the last time out. Come on. Okay, so I got 0 of 0. All right, let's take a look at our routing table. A little troubleshooting here, Cisco. Oops. See that again, it's all in caps. All right, show IP route. And we do have a route to that particular web server. Let me see what IP address I put on there. Oops, sorry. 222.1. Oh, lads. Yeah, what did I ping? 22222. How about that? 222.1. What's funny? Okay, here you go. So we got a reply. It's all good and dandy. All right, because, which way are we going though? Our gateway, let's find out. An easy way, a cool way, I'll find out without doing, a trace search, right? Because I think we can do that, right? We can do that on helpo. It's a different language. All right. Yeah, we can do a trace search. We can do a trace search to 2.2.2.1. And you see a tracer out. The first page we go to is 192.168.100.254. So, or we can, since I have telnet set up on the routers, we can also telnet into 192.168.100.254, right? That's our first hop right there. And then Cisco, and it goes to router 1. Okay, it's going to router 1. That's another way of actually doing that. So you can do a trace route, you can telnet, or normally you can do a path ping, however you like to do it, right? So what's happening is this is going this way, right? The path is going this way, boom, boom, and then that's the web server. So what happens if this goes down, right? So if this router's interface, the F00, and let's go ahead and do that, int, oh no, how about global, config T, interface F0/0, and we do a shut on there. That one went down. We got a red light on there. We try to ping the same. Let's ping. Now we're going to be out of gas. Now we're not going to be able to get anywhere, right? We're not getting anywhere because that particular interface is down. So we can't have that. So with HSRP, right, we provide this virtual IP address, or ghost IP address as they used to call it. And you put this IP address on all the routers. I believe it's up to 7 or 8, if I remember correctly, that you can use. All right, and it will generate its own virtual IP MAC address. All right, it'll create its own virtual MAC address, and it's separated. I did it here for you. You can see here you got, remember, each hex decimal is 4, so you got 16, right, and then 8 more, that's 24. So the first 24 bits is the Cisco vendor ID, right? The other 16 bits is specific to HSRP, and the last 8 bits are the standby group in hex. Whatever standby group you decide to choose, the last 8 bits will be for the standby group. This you need to be aware of, okay? Just make sure that you know the setup of the MAC address, okay? And here it tells you what you should do when you create the standby group. You have a primary, secondary, all right? The default priority is 100. We're going to change that, obviously. And then we have to reassign the IP addresses on the clients, okay? We verify, and then when we talk about tweaking, here are the commands right here. When we talk about tweaking, we talk about preempt, okay? We talk about preempt, we talk about tracking, we talk about the actual timers. Now, doubtful that you're going to be configuring this in the test, very doubtful, but again, Cisco can change their test at any time, so it's good to know. And you will be using this out there in the real world. You will use HSRP, okay? So it's good to know. It's good to know what the tracking and the timers and all that. We won't be changing timers. I mean, you can do it to milliseconds. I mean, seriously, changing to milliseconds where the routers talk to each other, say, "Hey, I'm still here. Hey, I'm still here. Hey, I'm still here. I'm not dead." So you can do that. It's completely up to you. All right, so you can do that. You can make HSRP look like VRP in the sense of how quickly the routers send hellos messages to themselves, okay, or the deads. So if they're dead, they can immediately pick up. All right, so let's go ahead. All right, what we're going to do is we're going to do a never-ending ping. Sounds like a song, doesn't it? Ping minus T, or the ping the IP. I always forget. Let's do a ping to the 2.2.2.1 minus T. See, I told you. Oops. Ping minus T. 2.2.2.1. All right. So right now we know we don't have any connectivity. Right? We've seen it already. And it's going to keep saying request timeout, request timeout, request timeout, and let it get going here. All right. So I'm going to minimize this, leave that black window right there, and I'm going to turn this interface back on. I'm doing no shut. All right. And let's see when it gets pings again. Obviously, you see a little buddy spang tree here. All right. And sooner or later, it'll start, once it turns from amber Okay, come on now. To green, we should start getting some pings going on here. And then we'll start the configuration of HSRP. All right, we turn green. Let's see when this request amount is going to change. So we can make sure we have connectivity. I didn't break anything just by doing that. Okay, we're getting our replies now. So cool. We got replies. Everything is going nice and dandy, right? But again, we're going to break it anyway because we're going to go ahead and start creating HSRP on there. And we do it on the interface, just like you see it right here. That's why I put it there. All right, so we're going to create this interface. We're going to be on this interface. We'll create standby group 1, and we'll put this IP address. And then later on, we can do preempt right from the get-go, and I'll tell you what that means. And then we'll set the priority. There's a reason why I chose 149 and for the standby 140. Because when you do tracking and you lose the track, this is the interface that you're tracking and it goes down, the packet tracer decrements or subtracts 10 by default. You have no leeway of putting your own number on there. So I try to make it where, maybe it'll work properly with that particular command, so the other one can become active and this one can become standby and so forth. All right, so we want this one to be our active router. So let's go ahead and go. We're in our interface already. So you can see I'll do a standby. Okay, is for HSRP configuration command. So that's the one that you do first. There is no HSRP command. It's a standby command. There is a VRRP and there is a GLBP, but again, that's not here. All right, so we can't do that here anyway. So we're gonna do standby group, right? Okay, you see here it says standby group number, standby 1, and then you want to put in the priority. Priority. Did I spell that right? Yeah, priority. And then we said 149. Okay, and really that's all you need to do. But we're going to put also standby 1 preempt. Let me see if I spell it. Yeah, preempt. It's right there in front of me. Okay, standby 1 preempt. Okay, I'm done with that one. Okay. Oh, and I got to put the virtual IP. Standby 1, and then you see it says IP, and we're going to put the actual IP, which is 192.168.100.100. I believe that's all we need to do. We need to put it on mask. Okay, cool. Oh, misspelled it. Standby 1 IP 192.168.100.100. Now 1000. That's a different IP scheme, and you hit enter. Cool. So let's do WR, sorry, and do show standby, and then you'll see here where it says it's still, the other one is still getting its configurations. That's why it's in speak. Okay, you see the virtual IP address is set. The active virtual MAC address is still unknown. It's still going through its process. Okay, hello, hey, it's gonna send me the router every 3 seconds. Hey, what's up? You see, boom, boom, I'm active. So let's do that command again. So you can see it now. Now I changed from speak to active. I'm active. All right, now you see that. Remember the first 24 bits I told you about? And then the next 16 bits, obviously the packet tracer puts its own particular MAC address. And then the last 8 bits is for your standby group, 01. Okay, because we're group 1. All right, and then the hellos. And then the active router is the local router. Standby is still unknown because we have no idea because we haven't configured it. And then we have a priority of 149. All right, so cool. So that's done there. All right, so let's go and let's see what's going on here with our pings now. Still pinging, not a big deal. All right, so we're going to go ahead and go to this router. And this is going to be our standby router. Use the same virtual IP address. We'll still do preempt, same standby group, but the priority will be 140. So we're going to F00 CISCO. All right, and config T. And then we're going to interface F0/0 standby 1. I always forget. Standby 1 IP 192.168.100.100 stand by 1 preempt, and I think that's all we did, right? Oh, and the priority stand. Oh, I missed. My God, tabbing has killed me. Stand by 1 preempt. Okay, and then stand by 1 priority. But the default is 100, so it's going to be the standby router priority. And we said that was 149. We said this is going to be 140. 140. All right. Do WR, Control Z, and let's take a look at the show standby to make sure that we got what we need. All right. So here it says we are standby router. This is the virtual IP address. There is your virtual MAC address right there. All right. That it generates by itself. The active router knows that the active router is 192.168.100.40. The standby router is local. Priority configure is 140. All right, which we did. So we've configured HSRP. Not a big deal. Now what we need to do next for this user or this computer to start using this is to change the gateway address. And before we do this, you can notice I'm going to break this. And I'm going to ping 192.168.100.100. We have connectivity to it, right? So that's pretty cool. So we're going to go ahead and change. All right, let's bring this in here. All right, and we're going to put this to 100 instead of 254. And now, first thing I'm going to ping, we know we can ping the 100. We just did. Okay. And then let's see if we can ping the, we don't want to do a -T, the web server, and we can. But which way are we going? Which way are we going? So we can do a trace search, and we're being lazy here. Trace search to 2221, hit enter, and it's still pointing out the other way to router 192.168.100.254. But we know that we're using the 192.168.100.100. So let's telnet to that virtual IP address. Cisco. And we're going to router 1. So obviously our tracer is going to go to the physical address on the router, but check that out. We went and put in the virtual IP address and we're going in the right direction. Cool. So what are we going to do here to see if HSRP is really working, right? So we're going to ping. Oh, wait a minute. Let's put the -T back in there. All right. Was it that one? Or was it? No, it was ping -T, right? Ping -T. There we go. That was the one. So we're going to start the never-ending ping. All right. And I'm going to move this to one side. Okay. And what I'm going to do is I'm going to shut down this interface and quickly come back to the PC. So I'm going to go to the interface. All right. I'm going to move this router here. All right. And see if I can get both of them on the screen there if I can. Well, you see you're getting your replies right there. Let me move this a little bit further so you can maybe see just there it says reply, right? Right there. Okay. Cool. So we're going to go ahead and do config T. And then we're going to go into interface F0/0. And I'm just going to shut it. And see, remember, the other router should take over. Let's see what happens. Let's see. Oh, there's our request timeout. We just lost connectivity with our web server. Oh my God, what are we going to do? Call everybody out. All right. Oh, wait a minute. Look, it's back up. Cool. Oh, it was just a glitch. Not a problem. All right. So we see now, all of a sudden, we just went ahead and started pinging again. So how is that even possible? So first of all, let's check that. All right. Let's check. Let's do our trace search. 22221. Well, now it changed. Look at that. Now we're going to 253. Okay. And if we were to telnet to the virtual IP address, CISCO, now we're going to router 2. That is awesome. Okay. That is awesome. That's something like that. We can do this, and it's been around, like I said, since 1994. Cisco just put it in there last year. All right. So let's take a look at what's going on here. Let's take a look at our routers. Show standby. And now this router is in initialization because his interface is shut down completely, right? Okay, so let's go into the other router. See what the other router is all about. Whoa, look at that. This guy says it became active. Now I'm the active router. And I still have a lower priority. Whoa, that is awesome, right? Now, the reason I typed preempt is so I can reclaim my role when I come back up. Okay? So now that you see that, well, now that you don't see because I'm not pinging anymore. Let's exit out of this router and let's do our ping minus T again. All right, and let's move it all the way so you can see the replies right there. And we'll get router 1 back up online here. Now let's shrink this, bring the PC back in. All right, what I'm going to do is go back in the interface and turn it back on. Config T, interface F0/0, no shut. So now that one's coming back up. And let's see if there's going to be any interruption. Boom, you saw the interruption, but look at that. Look at that. One request timeout. All right, I hope that's it. Well, okay, another request timeout. Okay, it's incrementing. We have the span entry still, the amber light, right, that we always get to see with span entry. So that's one thing to take in consideration. But definitely you don't want to take off span entry off these ports right here. All right, you want it to be looking at that. So it's a couple glitches. It's coming back. And hopefully that's it. Nope. Okay. Boom. Oh, here we go. So we got like 4 or 5 request timeouts, and then we're back again. So you see that now he reclaimed his role as the active router. Let's minimize this PC. It's getting me dizzy. All right. So we're now back as the active router. That is great. Show standby. All right. Now we're the active router. We're again, and then the other standby router is saying it's 253. Well, did he change back to standby router? Because remember he's saying, oh, look, he changed back to standby all by his little lonesome. Show standby. So that's what makes this great, okay? Having these redundancy protocols in place. Because if a client goes down, or one of the interfaces, if one of the routers goes down, an interface on a router, since the other routers, these routers are talking to each other every 3 seconds, hello, 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 I'm still here, I'm alive, okay? Then that router will go ahead and say, okay, I'm still standby. Once he goes down, if he misses that third hello, on the fourth hello, he say, wait a minute, he didn't send me anything? Okay, all right, he's dead. All right, I'll take over. All right, so then he takes over. And then, people just think it's a glitch, and boom, you're back up and working. All right, so this is the great thing about all these redundancy protocols. They basically do the same thing, just different configurations, right? And GLBP is really the one that has the load balancing because it has something called an active state, right? All the routers are pretty much active, where this is active standby. Okay, so this is HSRP in a nutshell. All right, but if you can see that the preempt command, all right, is there. So when the router comes back up, the active router comes back up, it reclaims its role as the active router. Now the tracking really is just so you can track the interfaces or interface above you. So if it goes down, it sends a message to the next router, hey, take over please. I'm tracking my interface to the WAN, and all of a sudden it went down. Can you please take over? And then he'll take over, and then traffic will change again. All right. So this is the purpose of HSRP. Definitely remember the little notes that we talked about. All right. As far as the MAC address, these things right here, very important to know. All right. You need to know this, the breakdown of the MAC address. So that's it. That's all there's to HSRP. I'll see you guys in the next lecture.